good for Windows. But any CAD software you go to, as long as it exports as a DXF file, you can use it. So no issue with anything that you want to use. File, and you always want to make sure you go to New with HiCAD. This will be just make sure that if you ever are at the table and you need to edit stuff, that you know what's going on. I do recommend probably making sure you get something that can export to a DXF 2000, just in case you get to the BurnTables computer and you find out, oh, I need to edit that. HiCAD needs a DXF 2000. Gotcha. SheetCam though, the next program we use, no matter what kind of DXF file it is, I've never had any issues with it or anything in. Okay. So if it's 100% complete, you can go right to SheetCam. In HiCAD, we're going to start about 30,000 feet above the ground. So you always want to start with a rectangle, and we're going to pretty much just put ourselves in the right scale for the table. So start with your rectangle. You're going to go to your first point, 0, 0, 0. The command line is always going to ask what it wants from us. So now it's going to ask for that second point. All we're going to tell it is where we want that top right to end. So for your whole table, we want to do it in inches, and we always want to do the long side first. It's going to be x-axis. So 120, 60 will give us that full 5 by 10. Enter. That's going to go ahead and draw that box for us, but you can see how far out of scale we are. Can't even see that box. View, zoom all. This is going to bring us right into whatever's drawn. Make sure we see everything on the page.
Can you just make, I guess you could probably just do that as a template that you save and just come into every time?
Absolutely. Yeah, you could definitely come to File, and we could export this as a DXF, and then you just always come in and import it, and then you can always start right in that 5 by 10 space. Okay. Now that we have this, we can really start to do whatever we want to draw inside of this. Do you guys are you going to be doing a lot of parts? Is it going to be a lot of artwork that you do? Kind of a mix of both?
Probably a mix. Right now, this is going to be like a hobby.
Okay.
Thing.
Absolutely.
And if it turns into something, then even better.
Okay, perfect. So parts, if you've drawn, and have you running a CNC router before? Have you actually drawn in CAD, or did you just operate the router?
No, both.
Both? Okay.
Yeah, I'm familiar with AutoCAD and several drawing programs.
Okay, perfect.
So I guess this should be good.
Yeah, this should definitely be rather simple for you then. Okay. The hardest part, it seems to me, for new people, is if you don't have any experience there. And then at least you'll have a little bit of time to practice and have you to help out. But the biggest thing is practice a little bit, stick with it, and you'll figure it out. But the drawing software will be the hardest part of the learning curve.
Like at YouTube.
Absolutely. And then any questions you have on HiCAD, you can always give us a call. Any other program, if it's actually about how to draw and stuff, we may not be able to help you. But we also have, there's a couple of videos that'll help you with HiCAD, but you can always go out there and find those other drawing softwares as well. With parts, a lot of times you'll probably start with either maybe your straight line, your rectangle, your circle. The only ones you want to stay away from are the polyline and the ellipse. Yeah. The reason why is even if you make this ellipse rather circular, you'll notice it's drawn with polylines. And so we end up with this string of straight little lines instead of an arc. So not only do you not get a circle, you end up with a bunch of straight lines. When the table cuts it, it kind of uses those lines to understand, or those nodes, where to go. So it'll kind of slow down a little bit, and when there's so many so close to each other, it just ends up jerking from one to the next.
Even if you put more blue squares in there, I guess it's just probably makes it worse.
Makes it worse, exactly. You always want to do less squares, less nodes. Where your circle is always going to just have the 4 around the outside, 1 in the center. But as long as you draw with your straight line, the rectangle, the arc, and the circles, you shouldn't ever see those polylines in your own drawings. For parts, a lot of times you can start with this straight line, and you can tell it exactly how long you want this line to be.
You stop in the inches after.
And high CAD will always be in inches, so we can do 12, enter, perfect 12-inch line. But you can tell it's not really straight. So, absolutely. Ortho down here at the bottom, we can start our line, turn ortho on, and then only 90s.
Yep.
And then we can do our 12 inches, perfect 90-degree 12-inch line. Then you can go up. Line segment's always going to expect you to want to do another line, so we can go next. And then if you're done, you can hit escape and we'll get rid of that line. From there, say you wanted to add to this drawing that we already have. If you just take a line segment and you click, you're most likely not going to be open. And you're going to be maybe close, but not right on. So we can always use our on snaps or object snaps. Make sure you turn them on. Ends, middles are ones I always use. And then we take our line segment and go right to the end. And then F8 is going to be your hotkey for ortho, so you can turn it on and off.
It's almost like AutoCAD.
Absolutely. Yeah, it's pretty much a free clone of AutoCAD 2000. So any of the newer AutoCADs may have a couple of different tools and stuff like that, but it'll be exactly like AutoCAD 2000. And then of course we have polar instead of ortho if you need any other angles, allowing us to. Starts in 30s, but we can change it to anything we want. Right click, settings, increment angle, we can go from 30 to 45 or 22 and a half, anything really you need to. And it's going to show you all those options as you go around. And that last number will always tell you the angle, 45, 12 inches, enter perfect 12-inch 45-degree line. I did find out, I just actually figured this out myself recently. There's a couple of options over here I wasn't even sure, I didn't even know about. This is kind of cool, the once feature or repeat. So normally, say if you're making bolt holes, we'll go make a bolt hole, and then we've got to go back and you've got to select a tool, then you've got to make your next bolt hole. You can actually switch this from once to repeat, and we can make our bolt hole, and make a bolt hole, and make a bolt hole, and it just keeps using that tool until you tell it not to. And then you can turn it right back to once, and it goes right back to just letting you do it that one time. And then one of them that was actually kind of weird too was rectangle select. There's actually line select, and you can just draw lines. Never seen that before. But all of these down here do stuff. Normally the only ones I use are ortho, polar, and the object snaps though. So let's go ahead and let's do this. So under tool, if you ever need to check your length, ever want to measure, make sure something's the way it should be, tool, inquire distance. This is going to allow us to use those snap points. And then it's going to tell us right here in the command line, distance, and then exactly how many inches it is. Right click and it'll bring up all the last tools you've been using. They also pop up right here. So then we can do inquire distance again. And then we can just go up 15 inches just like we told it. And then even cooler than that, in my opinion, we also have inquire angle. It will tell us the angle from x-axis, 45 degrees, but it also tells us the distance as well, of 12 inches. Just like AutoCAD when you're selecting, we can either click again, or you can use a box. And then we've also got two different kinds of that box. Where if you go left to right, it's solid, right to left is dashed.
Right, yeah.
Solid, everything inside the box gets captured. Dashed, anything the box touches gets captured. So we'll go ahead and get rid of this. And we'll get into something a little bit more artistic. So one of the things with CAD programs, of course, is sometimes you gotta get a little creative about artwork. Anytime I do stars, I normally start with my polygon tool. Do a pentagon, 5 sides. Start wherever you want, and just like a circle, it's going to let you kind of do whatever you want. You can use polar or ortho to make sure you keep it straight. And then I'm going to take our line segment tool, and I'm simply going to connect all these corners. Escape to get rid of that yellow line segment. And I'm going to delete our pentagon. So now we just have a star. Now, we want to get rid of just the middle. But if you try to delete the way we've been deleting, it wants to get rid of the whole line. Modify, and we have trim. Trim will allow us to get rid of the end of the line, the middle of the line, as long as we have some sort of reference to tell it where. Always going to want your cutting edges first. So you always want to say, if you want to get rid of this middle part, you want to select this line and this line, almost like a start and a stop. Enter to lock in those cutting edges. Then it switches over to select entity to be trimmed. Click on what you wanted to get rid of, and as long as we got those cutting edges right, it's just going to disappear for us. Trim is going to be a command though that wants to make sure you're done. So if you're done, hit escape and it just finishes.
You can draw a box.
Absolutely, yeah, and that's where I was going to go. Once you get confident with trim, you can actually do all those cutting edges at one time. Enter to lock them in, and then as long as we only click on what we want to get rid of, we can do everything at one time.
Kind of back up a little bit.
Mm-hmm.
Your parameter box that represents our table.
Mm-hmm.
Are those drawn lines?
Yes, those will cut. So when you are done, you will want to delete that, or you put it on a different layer, whatever's easier for you.
And that's what I wanted. There was some kind of other template that you couldn't. I got you.
Yeah, currently the way I have it, it is going to be an actual drawn line that you want to get rid of, but you could change it to a different layer, and that would allow us to avoid cutting it with the rest of the stuff. From here, I want to put a circle border around this. So I'm going to find the center of my star so I can center the circle to it. With a star, it's a little bit funny, where you want to take a line segment and go from corner to corner, and right where these two lines intersect is actually going to be the center of our star. So we'll take our circle tool, go right to the, so we don't have our intersect on, so all we have to do is go to our object snaps. When you click on them now though, they only turn on and off. So if you need to add options, go to settings, and I'm going to add the intersect. Now, we can click right where those two lines intersect. And with a circle, it's always going to give you the option for a radius in the command line. You can put it directly to a snap point. But in this case, I'm going to bring it just inside the circle. Click and it's going to leave it exactly where we put it. Go ahead and get rid of our reference lines. And then I'm going to go to modify, and I'm going to use offset to create a second circle perfectly offset from the first one. Watch out, because we started that 1,000-foot view, or that 30,000-foot view, we end up with some pretty high numbers in some of these settings. So 100-inch offset is probably way bigger than you want. Do something more like maybe 2 inches. Click, perfect offset. It'll do that for lines for you as well. And you can also do negatives, and it will come inside, or the opposite direction depending on what you're doing. Get rid of those extra lines we made. Now, All we need to do to finish this is actually trim these together. Get rid of the tips and then get rid of this little piece of the circle. So we'll go to Modify, Trim, and I'm actually going to select the whole star as well as the circle all at once. We need the circle to get rid of the star to get rid of the circle. Enter to lock it in. You just need to zoom in and start clicking. And as it all trims together, it's going to go back to being connected. So you don't have to worry about making sure that the two lines are touching or anything. It's going to automatically do that as long as you trim both lines like that. Escape to finish trim, and now we have our nice completed star. But we just don't know how big it is. So just like we did our individual lines, require distance, 42.3156. But say you either don't care how big it is right now, you just know how big you want it, or you just want to change something, modify, and we have two options. You have scale, and then you have transform. Scale is going to strictly be proportional. Everything's always going to stay looking exactly the same. Transform doesn't care how it looks, it will make it as big as you told it exactly. Scale is really good for artwork, especially on scrap metal, where say if you knew we had a piece that was 15 by 8 inches or something, we can tell it those dimensions and it'll make it as big as possible, but it's still always going to look exactly the same way you do it. So the first part of this box we can ignore. Use Object Profile Center. That's just going to keep the exact same center point. This would be if you wanted to change the location of the center point, but I like to move stuff manually so I can see exactly where it's going to go. Scale factor, this is only going to be half as big, 2 times as big, 3 times as big. The last option is where we want to go. This will allow us to give it instruments. Hit OK. And even though I put in 15 by 8, it makes it a perfect 8 inches by a perfect 8 inches, because that's going to be as big as it could make it and still look the same. But if you use transform, the box looks exactly the same. You go right down to the bottom. We put in something like 15 by 8, it will actually stretch it out and do whatever it has to make those perfect sizes. I pretty much always use scale, with the exception of maybe you started with a square and you decide you need to make it a rectangle or something like that. And then transform is fantastic and it'll make it exact for you. We're going to go ahead and use scale, and we're going to bump it up just a little bit bigger and go to a 12 by 12. If you were just drawing one of these and only wanted to cut one, we can get rid of our reference box and we're ready to cut. We can go to that next program. All we have to do is export it. But if you wanted to maybe cut a whole sheet worth, highlight the whole part, move it. I like to move it by just dragging it by the line. Be careful though, if you grab one of the nodes, it'll start to edit the drawing. But if we grab a line, it'll let us move it wherever we want. And I'm just going to go cinch it down here in the corner. You'll see as you start to overlap, it starts to turn blue. So you don't have to be super precise, but I just like to get it as close as I can. So a little gap's fine. And we're going to go ahead and highlight it, modify array. This will allow us to repeat that part across that entire sheet if we want to. So base points, we can leave those. Those are just coordinates picked by the computer. Rows and columns, this is a number you can kind of guess on, because we can always delete anything that doesn't fit. The offset though is pretty important. I recommend a 1/4 inch in between your parts, but we can't just put 0.25 here, because it actually offsets from the beginning and you end up with everything stacked on top of each other. So you want to put in your whole part distance, 12 inches, plus the offset that you want. And then this happens to be symmetrical, so we can use the same on both. Hit OK. And because of that reference box we started with, you can very easily see and none of that fits. And then we have exactly what we can fit. A lot of times though, you'll find out, modify, and we're going to use copy just to get one of them. A lot of times you can actually stagger them around and maybe even find a couple other places you can fit something. And then I also really like that we can file. We can actually go open a completely different drawing, import. And we can bring in a completely different drawing, and you can copy it from here and paste it into the drawing we've been working on. The only thing to watch out for though is if we just copy it and paste it, it uses the exact same coordinates. You can always undo. You have your undo and your redo buttons up here. Control Z works. And then I also really like, you can just type the letter U, hit enter. And that is also an undo command. But what I'll do is I'll take our piece and just move it down below 0 a little bit. Control C to copy. Control V to paste. Now we can size this appropriately.
Can you not just put a box around of it and drag it?
No.
Shrink and stuff?
No, that's one thing that didn't come over. I think that may be something that's newer than AutoCAD 2000. And I think that may be why it doesn't do that. But I haven't used new AutoCAD very often, and I didn't even know that you could do that. And then I started getting questions about that, and I was like, I wish I could do that. But then we can go ahead and put it wherever it fits. Modify. Copy. We've got a couple of these out as well. And then if we need to, we'll bring one over here. Modify. Rotate. Pick a reference point if you'd like. And then you can even just tell it 90 degrees. Hit enter. And you can find somewhere it fits. And that way you can kind of go through and really fill your sheet up as much as you can, and not have any scrap, or you can have scrap and work with that later if you need. Right now, say we're done. That's all we want to cut out. We're going to go ahead and delete our reference box. File, export, DXF vector image file. I'm going to put mine on my desktop for now. You will have a drawings folder on the BurnTables computer if you ever draw on it, where they automatically save, but you can always use a flash drive to bring files from your home computer or your office computer. We're going to go ahead and I'm going to save over this file I already have. And now we're done here in HiCAD. We'll come back and I'll show you a couple more things before we're done today. But I like to kind of go from HiCAD all the way through so you get a feel for exactly the whole process, not just kind of one thing at a time.
Yeah, I'm not familiar with HiCAD, and I don't know. I don't know if I'll use it, but if I can use CAD, then I'll do that. And
yeah, this is going to be SheetCam. This is going to be the software that actually takes your drawing and lets you apply a toolpath to it. Tell it how to cut it, what you want to do with it, and what tool to use. Yours will already be set up to the right size for your table, but let me check mine. Okay, perfect. You already have 5x10. So this red box technically represents your material. There is a way to change this every time to your different material sizes if you're working with a 4x8 instead of a 5x10, but it's not necessary. It's only for your reference. I normally leave mine at my whole table size, but if you ever want to change it, just let us know. We can walk you through it. So the first thing you want to do is make sure you have the tools necessary for whatever you're about to cut. For your plasma, it's going to be a different list of settings for speed, and kerf for the different materials and the thicknesses you're going to cut out. For your router, you'll have tools for the different bits you use. For the engraver, there'll just be one tool, and you'll use that every time you use the engraver. The tube notcher uses your plasma, so you'll just have tools based on the thickness of the pipe you're working with. So you'll have one already set up for you, plasma, 10 gauge, 45 amps. This is perfectly set up to cut 10 gauge, 45 amps, but it's really there for kind of a, to let you know what your tools should look like. So we're going to go ahead and just pick one and delete it and remake it. Let's get rid of this 45. So when you make a tool for your hypertherm, they make it nice and easy. Really, most of the settings we're going to need are going to be right in the hypertherm manual for you. Okay. So to create a new jet cutting tool, as it's called in SheetCam, you'll have this button right here. Hover over it and you'll even see it say create new jet cutting tool. Jet tool name doesn't matter for the way it operates, but I do recommend naming it something like this. Whatever tool it's for, whatever thickness you're working with, and then whatever amperage you're going to cut. With your 85 amp machine, you're going to be able to cut 85 amps, 65 amps, or 45 amps, and really anywhere in between. But those are going to be the three kind of main tiers that they have consumables for.
What type of material can you cut with this?
So with that machine, you can pierce up to 3/4 of an inch. You can cut a little bit thicker, but you would do what's called an edge start, where you'd actually have to be about halfway on and halfway off. Right. And they don't rate what it can edge start, so I'm not sure the rating on that, but an actual pierce straight through material, you got 3/4 of an inch. The type will always stay plasma for the plasma. You also leave the type plasma for the engraver. When you make your engraver tool though, in the engraver section, your software manual, there's an exact copy. I would just copy it in your SheetCam and use it. Because we've already kind of done the work on figuring out how wide the engraver is, what the best speed is, all that sort of stuff. The tool number does not matter at all for how it operates, except for the engraver. You'll notice mine is tool number 101. As long as you copy that tool out of your manual, you'll get that tool number as well. Kerf width and feed rate. These are the only other two settings we're going to need to change, and these come from the hypertherm manual. Pierce delay all the way down, you're going to leave these the way they are, and we're going to set those settings with the actual control box with the automatic tool type control. So you'll have a hard copy that comes in the box with your plasma cutter, but I'll go ahead and pull up my digital copy so we can at least go over it. So you'll have this manual, the Hypertherm PowerMax 65, PowerMax 85 plasma arc cutting systems. They've changed the page numbers a little bit. I'm not sure what they added, so yours won't be this exact page number. But what you're looking for is the estimated kerf width compensation guide. This will give you, based on the type of material, the thickness, and the consumable you're using, what kerf you should use. We've got settings for mild steel, stainless steel, and aluminum. The first page is metric, then the second page is English. You always want to work with these shielded consumables. Since you got a machine torch, they're always going to be the shielded consumables. Fine cuts you want to stay away from. They don't work well with the torch height control. The nozzle is so small that it tricks the torch into thinking it's diving the whole time, based on the arc voltage, and so it just wants to raise while it cuts. So if you use a 45 amp non-fine cut, it's still going to be a fantastic small curved cut, but you don't have to worry about your torch height getting upset with it. It'll actually operate correctly. So we're working with 14 gauge, 45 amps, and let's say we're working with mild steel. So right where all that lines up, 0.055. Come right over to sheet cam, type it right in, and it'll put that label inches right back for you, so you don't have to worry about that. Feed rate, same place, manual. Then starting on the next page, we've got 85 amps, mild steel, and it'll give you all of the feed rate recommendations. Stainless steel, then we get to aluminum, then you're going to go through the 65 amp, 3 pages, and then you'll get to the 45 amp. They'll all have the part numbers for what you need if you want to switch to those different consumables. I'll tell you though, the only part number that's different is the nozzle. No matter what you use, you always use the same electrode, same scroll ring, same everything else. So 45 amp mild steel, we'll skip over the metric, come down to English. 14 gauge, since we're doing the automatic torch height control, and we're going to set that with the control box, don't worry about this first set of information over here. We just want to worry about the cut speed. You've got your best quality, which is normally what I stick with, but then you got your production setting. Maybe you're doing a large run of parts, and it's something that's going to be heavily welded or machined on afterwards. They'll give you both of those speeds. The 14 gauge, it looks like we're looking at 270 for our best quality, 320 for our production. The kerf width, I always stick with that kerf width number they give me. The feed rate, I'll start with their recommendation, cut a couple of parts and see what I think about it. Don't be afraid to adjust that cut speed a little bit if necessary.
Does it get, well, I guess just haven't seen this part. I hadn't messed with the plasma. So
Okay.
I guess it just changes what the edges of it.
Exactly. So the edges, and then the biggest things are going to be your edges and your slag on the underside, the amount of work you're going to have to do to clean it up. If you're going too slow, you're normally going to have a lot of slag going on because there's a lot of heat in there. If you're at the speed that you need to be, a lot of times you'll have on straight cuts very, very little slag. Plasma, you will always leave a little bit, but I have seen, especially on my straight cuts, if you get those speed and those height settings where you want them, almost zero slag on some of those straight cuts. But we'll go downstairs before you leave and we'll kind of cut a couple things out and I'll describe to you kind of what we're seeing and give you a little bit better idea what you're looking at. But a couple of cuts and you'll start to kind of learn based on the slag and how much of it, where it is. If you've got it on the top, that can mean that you're cutting too high or too fast. If the cut doesn't go all the way through, say, especially one of the biggest indications of you're going too fast, say you cut a square. All 4 lines don't make it through the material. Every corner makes it through the material. It has to slow down just a little bit to turn and make that corner. So to me, that sounds like when it slows down, we're making it through, and then it speeds up and it's going too fast to cut.
So if you was to pick a 14 gauge metal, so I mean, does it automatically go to 270 inches per minute? Or?
So it kind of throttles itself. It will accelerate from 0 and slowly get up to that speed.
Yeah.
But it will also, around corners, long arcs.
Slows down.
Exactly. Anything that it understands. If I try to make a 90-degree left turn at 270 inches per minute, it'll slow down to what it needs to be accurate. And there's actually a part I'll show you in the control software where it'll actually show you how fast it's moving right then, and you can get a kind of a better idea how it moves and when it decides to change itself. So we're going to stick with that best quality in this case. We can go right here, 270. All these other settings we can leave exactly the way they are. Hit OK, and it's just going to simply put our tool right over here, tool 9. So the first time you close out a sheet cam, after you make a tool, you want to save your changes. You actually don't have to save your changes, but do you want to save the default tool set? Absolutely. If you want to keep whatever tools you made, make sure you hit yes. Then the next time you open sheet cam, that tool is going to still be there for you. If you accidentally hit no, then it will delete that tool and then it won't be there the next time you open it. So now that we have the tool we want to work with, you go to File, Import Drawing. Find our drawing, mine was on the desktop. Hit Open. You're going to always get this drawing options window when you first import a drawing. Scaling, whatever you drew it in. In our case, we drew it in inches, so you always leave it in inches unless you draw in metric. Drawing position, yours will start on drawing origin, and that will leave it exactly where you drew it. I like drawing position, bottom left-hand corner. Perfectly puts it in this bottom left-hand corner, regardless of where you drew it, how you drew it. It'll kind of cinch everything down in the corner for us. Hit OK. Bam. And it should look a lot like it did inside our reference box in iCAD. Yeah, puts it right on that edge. And then how close you actually end up to the edge of your material all depends on kind of where you put your zero with your torch. You're going to have the option to move your torch and zero it exactly where you want it every time you cut. So that way if you're working with full sheets, you can put it in the corner. If you've got a piece of scrap up there, you can put it in the corner of the scrap instead. Whatever's best for the project you're actually working on. You'll see a little bit difference in color though here in SheetCam. Red simply means that this is a part. You'll see that all of our parts are kind of outlined in red. Yellow means that this is an inside, and these are the same part. This allows us to kind of do half the work and only set up an operation for the outside, and then it's going to automatically flip it for the inside and give us that inside offset so we don't see any pierces. White means open pad, simply not connected. If that's how you wanted it, like I did in this bolt, that's no problem at all. If we start seeing white lines in some of these yellow cuts where we actually wanted them to be closed, that can be a problem. And you'll want to go back to HiCAD or your drawing software and adjust it. But if you want them, they will cut, no problem.
Are the bigger little squares on there, they pierce points?
Yeah, you'll see in here they're going to be, once you get close, there'll be little dots. But yeah, all those white dots are going to be your nodes. And then here in a minute, you'll actually see on the white ones, it'll be your pierces. Here in a second, it'll show you on the closed paths exactly where it's going to pierce.
Can you move that around?
Absolutely. So normally, I let SheetCam do its thing. It has a very powerful automatic optimization, I guess is what you would call it, where you tell it what offset to use, what tool to use, and what layer to apply it to, and it's going to do all the work for you. But if you see something you don't like, you can always change it.
When you say you have piercing, does that mean it's not going to cut all the way through?
So no, the pierce is going to be the first place where it starts a cut, where it actually fires and goes through the material. Then it'll move into the cut and cut all the way around.
Well, I'll tell you what, while I'm thinking of it, let's say if you wanted to, you have a flat piece of metal, and you're going to put that bolt up there. Can you go to where it won't pierce that whole metal, it'll just go?
No, not with these plasmas.
Okay. I just checking.
There are plasmas you can do that with, but those are going to be kind of your big HD units. A lot of those run like almost like 25K by themselves, but they're like super high amperage. They run off oxygen instead of compressed air. But some of those you can actually dial them back and do, I guess what you would refer to as even engraving almost with the plasma. With this, you could do it with the engraver, where we could do it, the engraving and the cutting at the same time. And it'll come through and it could engrave all those lines for us, then cut the outer bolt. But you wouldn't be able to do it with the plasma cutter itself.
But this machine does have a tool that could be applicable to what you were just saying?
Absolutely, yeah. The engraver could absolutely, and they're mounted right next to each other. The plasma's here, the engraver's here. So if we do it right in the drawing, we can set it up where it'll come in, engrave all of those inside lines for us, come cut that outside point for us. So once you take a look at all this, and everything looks good to me, we've got our red and our yellow. The only thing that's white are the lines we want it to be. You go right here to create a new jet cutting operation, and this lets us combine it all together. Contour method. So this is always going to be for the red line. Outside offset, inside offset, no offset. I only ever recommend no offset for your engraver, so that way it comes down and kind of draws directly on that line. Outside offset is usually what you're going to use for that red line. Every once in a while, though, you may find something where you need to use that inside. Layer, always going to be default when you draw your own stuff in iCAD, but if you get someone else's drawings, sometimes it may be a different layer name. If that's the case, if this is ever blank, just click on the drop down menu and select whatever layer name is in there. Then we can select whatever tool we want. Max chain length, overcut, you can just ignore those. Offset open paths, lead-ins on open paths. These are silly in my opinion. When I cut straight lines or these open paths, these white lines, it's normally because it's for detail, but I didn't have the room to do a full cut there. So I want it to be normally exactly where it is. I didn't draw it for it to put it off to the side. So the offset will kind of put it off to the side a little bit. Lead-ins will actually give you a little swoop that leads into the cut, and then now you're going to have a little bit of extra detail on every line. So I normally leave them exactly as they are. Reverse cut direction, though, you do leave on. The plasma is kind of interesting where it comes out of your plasma head actually spiraling, and so if you drag it across the material one way, it can have kind of a poor effect because of that spiral. So when we reverse it, it actually makes a much cleaner cut, specifically on your small circles and a lot of smaller shapes like that. So if you just leave it on, it's a better way to cut. Lead in and lead out, you do have the option to adjust these however you like. Yours will be already set like mine are, and this is the way I recommend. Arc 0.2, arc 0.05. That kind of minimalizes them, but keeps them long enough that you don't see your pierces in your actual cuts. If you ever do start to see pierces in your cuts, I want to say it's that one over there, the coaster near the end of the table. There's one that, yeah, on the edge there, you see that little mark? Here? Yes, that's from a pierce that there's two options. Either the pierce, the lead in, wasn't long enough on it, or the consumable may have been needed to be replaced. And so the kerf on the consumable is a little bit wider than when it started. But if you ever see stuff like that, normally it means make your lead in a little bit longer or your lead out, and then you won't see that sort of stuff. And with the engravings here, I keep that one on the table to kind of show you what happens when you go a little too fast, where you start to see every little punch. Where the spider is going to be a much more good engraving, where it's going to have a solid line that goes through. I recommend about 20 inches per minute on the engraver. You'll see that on the tool in your manual.
Did you get that engraver?
And of course, aluminum is going to give you a little bit of a deeper pass on the first go. I've got some people that do double passes. I've even got one of the cool, I've done it myself, but I was talking to a customer recently, and we were kind of discussing where if you set multiple operations to the same thing. So you've got your engraving, and maybe you want it to be a little bit thicker and more noticeable. Set up a on the line cut, then an outside offset or an inside offset. And then it's going to come in, but then it's going to come in right next to itself and do the exact same thing. Kind of give you a little bit more width. Yeah, exactly. Or you can always do bubble letters where it comes in and just does it and makes it nice and big for you. The engraver is really handy for part numbering, artwork especially. Once you get into smaller stuff, it'll allow you to put a lot of extra detail in there that the plasma could never be able to do for you. Material thickness, you can always leave exactly the same. It's going to be part of the torque tie control where it kind of just lets it take over.
Now, yeah, as far as the how hard it the
Mhm.
engraver's hitting.
So there's a regulator for that. That you will have to change based on material.
Okay.
But you can normally, what I do is I have a test I like to do. It's just a circle. It's kind of about the size of these coasters. It's got it engraves a circle. It engraves two straight lines, kind of looks like a crosshair, and then cuts the whole thing out. What that does for me, it allows me to dial in my engraver, make sure that straight lines and the curve are engraving the way I want, and then the offset's correct. It comes through as a plasma, and that'll show you if everything's lined up or not. But I always like to do that when I switch to a new thickness, so that way before I actually start my project, I can do something simple and I know everything's the way I want it. And then loop sharp corners. This is something that I don't ever really use, but it's there for you if you need it. Anytime you cut a 90 degree, as the plasma comes up, it's got to slow down and turn. And so the corner itself can end up rounded just a little bit. Loop sharp corners will make it come up, come back again. And so you end up with a perfect 90 degree because it never turned and it never slowed down while it actually made that corner. Normally though, the roundness of the corner isn't going to be something that you'll notice unless you're pretty close to it. So unless you're really needing that perfect corner, it may be something you never use. But it is there if you need it, and you've got the triangle and the arc version. But none, we'll keep it off. You can hit OK. And once you hit OK, that's going to apply your drawing to the actual, or your tool to the actual drawing. Everything green is going to cut. Everything blue is the fast travel in between cuts. All your S's are showing exactly where it's going to pierce. Read in, read out. You can see on our open paths, it just pierces, makes a nice little line. The biggest thing you want to look for is multiple pierces in one cut. But the nice thing is since we erased this, we can look at one of them. Every one will be the same. But as long as everything lights up green, we don't see any double start points, we're ready to move to the next step and actually cut it out. So you want to go to Run Post Processor. But you'll notice as we head up there, we've got this little exclamation mark. Normally, so the yellow triangle with the exclamation mark means that this is a warning. It's not necessarily that something's wrong, but there's something it thinks you may want to take a look over. In this case, open paths were not offset. But like we talked about, I want to leave them exactly where they are in this case. So that's just fine. But you could double click on it and we could change the setting if we want to. If this ever pops up as a red circle with an X in it though, then there's an actual problem, and more than likely it's going to try and tell you we can't even cut this for whatever the reason is. Normally, I'll tell you number one reason, there's no layer selected. And all you got to do is come in here and select a layer. But as long as everything's the way we like it, Run Post Processor.
So you might do one layer engraving and the next layer will be
cutting. Exactly, yeah. And we'll come back and I'll actually show you how to set those up together. And you can name it whatever you want. Since they're different file types, you can always name it exactly the same as your drawing, so that way you know that which cut is for which drawing. I'm going to go ahead and replace it because I already had one with the same name. That little white box pops up for just a second. As long as nothing went wrong, it just goes away. If anything were to go wrong, it'll stay there and tell you what happened. BurnTables, this is going to be the table control software. You're going to have a couple of different options on your desktop. BurnTables Plasma, is router, BurnTables Oxy 70, and then BurnTables LaserDim. LaserDim is going to be for your tracer. The other ones are just for the corresponding attachments. Whenever you're using the plasma, just grab BurnTables Plasma. When you're using a router, just grab BurnTables Router. And really the difference is going to be which tool it actually tries to turn on. So when you get to the program, they're all going to be the same regardless of which attachment you're using. Reset button is always flashing when you first open it. Make sure you click it and get it to stop flashing, or we won't be able to do anything. Once we reset that button, you can use your keyboard to move the table around. Left and right is going to be your x-axis. Up and down is going to be your y-axis. Page up and page down are going to be your z-axis. The x-axis is always going to be the long, the 10-foot side of your table. The y will be the short, that 5-foot side of your table. And then the z is the actual height of the torch itself. You'll, with a plasma, want to actually bring it down until it barely rests on the material. You'll do the same thing with your router, and that's how we can tell it not only where X and Y is, but exactly where the top of the material is. Once you move it to that location, X, Y, and Z, 0. Hit 0X, 0Y, and 0Z. Sometimes they may end up as a negative instead of a positive. As long as it's 0 though, that's all we have to worry about. You would turn on your torch height control. Little green square turns on, that lets you know it's on. In my case though, we're not hooked up to a table or a plasma cutter, so it'll get mad at me, so we'll leave it off for now. Load G-code. This will actually allow us to open that file we just made. All the code pops up over here. A picture of our drawing, a lot like what we just saw, pops up over here. And here, the only difference in color, blue is straight lines, this kind of pinkish purple is a curved line. If we were ready, we've got our picture zeroed out. You would have your torch height control turned on. Cycle start. Torch is going to pick up, move over to your first pierce point. With the torch height control turned on, it's actually going to go down and find the material, raise back up to our pierce height, fire. As long as there's material underneath it and it makes contact, it's going to start moving from there. In this case, the machine is going to be doing a dry run, where you would have your torch height control turned off and your plasma cutter turned off, and it actually comes down to about a ½ inch above the table and just starts drawing your parts out, so you can kind of get a look at what it's going to do before you do it. That's always good if you get it set up before you have power to your plasma, before you have your ground rods hooked up, anything where you just would rather not fire that plasma, but you still want to take a look at how it works. And then for the most part, this step's going to be just kind of letting the machine do its thing, watching over it, and make sure everything's working correctly. You'll see this bar flash anytime that the plasma is being told to fire by the computer. This over here is going to be our feed rate based on the tool we made. This green bar allows us to change the speed while it cuts. The movement. We'll be able to change so your machine can't go quite this fast, but this is going to be our feed rate we started with. This is going to be the new feed rate, whatever we've done based on this adjustment. This is your real-time speed, showing you exactly as fast as it's going right now. Reset takes you right back to 100 where we started. Anytime you've overridden the speed though, this little bar will flash red. Also, if you say we've got our speed cranked up and for any reason you stop the table, when you hit stop, it resets your speed as well. So make sure you ramp it back up to wherever you had it when you started it. If you ever have, especially when you're first getting started, setting up your torch height control, maybe you forgot to turn your compressor on, anything that happens where it doesn't fire or it stops while cutting, we can always go back and restart at any pierce point. You can't start in the middle of the cut, but we can start at any pierce point. So all you have to do, one thing that's helpful, let me zoom in a little bit here, but you'll see that it actually lights up the lines in our drawing here. As we scroll through the code, So if that's the cut we need to restart, scroll up to the first M09, M05 code you see above it. Set next line, cycle start. No matter what it was doing, it goes back to where we told it, starts that process over again.
If I put the wrong line on there, you said that.
So if you don't go to the M09, M05, there's a couple of options what can happen. The only one you absolutely want to avoid is the M03. If you go directly to the M03, that's the pierce code, but it doesn't tell it where to pierce. It strictly says pierce.
Oh.
So if you go right to it, it will pierce exactly where it's sitting.
Yeah.
The M09, M05 though, what that does is it's a transition between the cut. So it tells it exactly where to go and then tells it to fire. But if you start anywhere in between those or after them, what can happen is it may go to the right place and it may never fire because we're past the pierce code. And it may just kind of draw it. The other thing I've seen is sometimes you may literally grab a code that is like halfway between a code and it doesn't understand that code out of context and it gets upset and it won't do anything. And all you got to do is just find that right line and then go to it and it'll fix itself. For the most part, you're not doing a lot with Mach 3, the BurnTables software. You're really just kind of letting it cut, watching over it, making sure it's doing what it should be. But, like I said, we can always start at any pierce point as you go through the code.
So you find the M09, M05, and you select the line above it?
So, you actually select the M09, M05, and then set next line. But if you want to restart with the cut you're on, you always want to go upwards to the last M09, M05. If you wanted to skip to the next one, you can scroll down to the next M09, M05. But they'll be between every two cuts, and it's just kind of a guaranteed code that allows us to go back and know we're going to be able to get to the right spot and fire a torch. One thing to watch out for here in this program, so we can zoom in and out with the mouse wheel. You can even pan around. Make sure you use the right click though when you pan. If you use the left click, it goes into a 3D motion, and that is not a lot of fun. Double click though with your left click and it'll go right back to the way it started. Then we can use that right click to pan around. When you're going through your torch height control setup, you will need to change this anti-dive speed. In the manual, I've got some really good instructions on how to go through and set up that torch height control. You'll hear it or you'll read it reference the anti-dive speed. There's a point where we're going to change this number. So when you get that to that point, just know it's right here. Big number with a percentage sign, anti-dive speed. The words themselves are kind of small, so every once in a while I get questions. Oh, hey, where's that setting at? So I like to point it out. And then when you change it, make sure you click, type the number, and then hit enter. If you don't hit enter to lock it in, it'll go right back to wherever it started. Let's see, I think that's really about all for the plasma section on Mach 3. This software is really nice where there's not a lot you have to do. Mainly it's really just letting the machine cut. One thing to watch out for though, there is this go to 0 button. If your torch is against the material or below the material, it doesn't pay attention to that and it will drag it on home. So if you ever
didn't pay attention to what the zero.
Exactly. It will bring it back to 0, but not until it's gotten home, which is kind of silly. So if you ever hit that button, just make sure your torch isn't against the plate when you do it. But we'll go ahead and we're going to go back to HiCAD. And we're going to do the difference and I'm going to show you how to engrave something. So say if we wanted to, kind of like the coasters here, if we wanted to engrave the inside and cut the outside, all we got to do is put them on 2 different layers. But first we need to know if we even have 2 layers. Layer manager, default, so we still need 1. Create, engraver, And then color, you don't have to do this, but I like to change the color so we know exactly what's on that layer. Is it okay? And then we're going to simply select everything, and I know I missed one, but this is why I like to, you can easily miss one real quick. So all you have to do is switch it over to a different layer, click on whatever you want to change, right click, change layer. I just used it so it's at the top, but normally it'll be down here a little bit. Click whatever layer you want to switch to, and okay, moves it right over for us. And if all we wanted to do was cut one of them, engrave the middle, and then cut the outside, that's all we have to do, and then export it as its own DXF. Call it engraver, save it, and we're going to come over to SheetCam. Watch out, if you leave these operations here, if the next drawing has the same layer name, it'll automatically apply it. And sometimes that can get you in trouble. So I always like to delete my existing operations. Import drawing, go to our engraver, inches, drawing position, bottom left corner. It's going to ask me if I want to change the part name or the drawing name as the job name. Sure. Since it's two different layers now, we're going to have all red instead of those inside parts. Because now it sees this as one part and then this as another part. So you'll want to make sure you make your engraver tool. Already have it in the engraver section of your software manual, and it's going to look just like this. Then we'll come down here to create a new jet cutting operation, just like before. But this time, we're going to do no offset. You always want to set up your engraver first before you set up the plasma cutter. Layer, engraver, tool, engraver, lead in, none, lead out, none. That way, all it does is comes in and just draws our lines into the metal. Then, create a new jet cutting operation. This time we're going to go back to the outside offset, the default layer, and our plasma tool. Arc, and arc. And then you'll see we actually now have two operations, and they're clearly different. The only other step you have to do before you be ready to make this file is set up the offset of your specific engraver. Very easy to do. It'll walk you through it in the engraver section. But all you do is you take a piece of material, it can even be this big, and you'll just move your engraver over, or sorry, move your plasma over, zero your plasma about 1/4 inch off the material, and in the control software, you'll be able to hit this torch on off button over here, and it will fire that plasma, and you'll just put a little pierce hole in there. Then, you'll move your engraver over to match that hole. Drop the engraver down. Without air to the engraver, it'll actually let you just pick it up and down on the slide. That way you can drop it right down into that hole, make sure it's perfect. Then you're going to have some X and Y coordinates here. It'll remind you in the manual, you're going to actually want to turn those coordinates to millimeters from inches. Even though we work in inches, SheetCam actually works in the background in millimeters. So you'll convert them, bring them over to SheetCam. And I've got pictures in the manual to show you what it does. But you'll go to machine, post processor, edit post, and we'll simply put those numbers right here next to scriber X and scriber Y. Just be careful, if you accidentally put a positive sign in there, it does need the negative if it's a negative number. But if it's a positive, just leave it blank in front of it. If you add that positive symbol, it doesn't understand the plus sign, and then the whole post processor doesn't work. But it gives a really specific command, so if you ever accidentally do that, we can figure it out. And then you'll just save it after you've edited it, close it. Then when you make your file, your offset's going to be correct. Call this engraver, go ahead and save it. Because of that offset, when you load your engraving into Mach 3, you get kind of an interesting result. because this is where your plasma is going to be, while your engraver is actually in the correct location engraving.
Okay. Because they're both on the, that's.
Exactly. Yeah, so that way when we decided to add an engraver, now we track the plasma and just give it an offset. And then you would have your torch height control on, just like you would for a normal plasma cut. It's going to come over, and as long as you tune the pressure of that engraver to the material you're working with, it's going to come over and just start engraving for you. If you're working with full sheets, you don't have to worry about it too much. But if you're working with scrap, definitely highly recommend either weighting it or clamping it to your table. The engraver will absolutely bounce some small scrap around and even slowly move it as it engraves. But I've just got a couple of 1/4 inch plates pretty much, just some little rectangles, and I'll just throw them on either side, and even small scrap will be fine that way. But the engraver operates a little bit slower than your plasma does, so you'll see it's going a little bit slower through those. It'll go through all 5 of these, and then it's just going to come and just shoot right through that outside cut. So your router is going to be very, very similar. Where the only difference is instead of one layer for engraving, one layer for plasma cutting, you need a different layer for every different depth that you want to cut. So if we're doing one depth, one layer. But once you start trying to get complicated, you may need a couple in there. So I'm going to go ahead and I'm going to add one more shape in here. Nothing fancy, just a little rectangle. And we're actually going to put it on a 3rd layer. With the router, I like to label them based on kind of where they are. Because I always like to start from the inside of my router and work outwards. Right. Inside off, and then we'll start with our inside layer and export. And then everything else is going to happen. We'll go ahead and delete our operations. Import drawing. Inches, bottom left hand corner, just like before. You want to use the drawing name for the job name, yes. So we're going to have 3 different red sections. You'll want to make sure you make a tool for whatever bit you're going to be working with. If you get into real complicated stuff, let us know, and I can email you over the instructions on how to. There's also what's called a tool change, where it's not going to be automatic, but we can add a code in there where if you wanted to say maybe remove most of the meat of your project with a big bit, and then you want to come back through with your detail. We can always do the first one, set a pause in there, then the second one. What that allows you to do is it'll do its thing, stop itself. When you have the time, or whenever you find that it's stopped, you walk over there, you switch your bits out in your router, and you hit start again, and it goes right back to finishing.
Yeah, I'll probably use it in that.
And it's very easy. All you do is insert code. Yeah, this one. Create a new code snippet, and there's just a very specific set of letters and numbers we have that you add in there, and it puts it right in between the operations. And I'll show you before we're done as well. The router is capable of full 3D. The plasma, just because of the way the plasma cuts, we're stuck to 2D. But because we do have 3 axes, the router, you can do 3D routing. With sheet cam can't really handle 3D. It does 2.5D very well, but not 3. But we do have a YouTube video that walks you through a program called FreeMill, and it's going to be a free program you can use to do 3D. But there are other ones I've seen people use. I want to say maybe Aspire. I'm not really familiar with a lot of the 3D routing programs, but there's a couple of them out there that people have had luck with. The biggest thing is FreeMill is going to be the only one we've worked with. So the settings you may have a kind of a tricky time figuring out on another program. But once we have our router drawing in here, we can make our bit, create a new rotary tool, looks like a little drill bit. Just like your plasma, I recommend naming it something that shows exactly what it is. Router, 1/8 inch, and then maybe if there's something special, in this case, maybe it's a V-card. Mill router will always be your type. Tool number doesn't matter. Diameter, flute length. These are actually the only things we're going to need to worry about in this screen. All these other settings will actually be presented to you again when we set up the operation, so we can change them all then. The diameter and the flute length, though, purely based on the bit you're using. How wide is it? How long is it sticking out of the actual router? Hit OK, and it's going to put it in the tool right over here. Then we have to actually cut. We've got 2 different ways to do it. Create a new pocket, and then contour. Pocket's going to allow you to do partial depth, but remove the whole space. Contour is going to be just like a plasma cut, where it just rides the line and tries to cut out. Pocket, we're going to start with the middle, and I'm going to pocket that very middle piece. So I use spiral and zigzag pockets. Zigzag for my squares, rectangles, things like that. Spirals for anything with a big arc, circles. So we're going to do zigzag. We're going to start with our inside, our router bit. Start depth, we're starting right at 0 against the material. Cut depth, this will be your final depth you want to go in. So maybe we're going to do 0.25 here. Depth per pass, how much do you want to do at one time? Step over is really important, where if you have this too high, you'll have a really rough surface at the bottom. Fill angle, finish allowance, you don't have to worry about that if we're working with a CNC mill. Feed rate, because there's so many materials, so many bits that you can use with the router, we don't really have a good feed rate guide. I recommend starting about 40 or so, and then using that green bar in the router software to actually adjust that speed and figure out what you like. Plunge rate, you could speed up, but I like it 10. Makes it nice, smooth, pierce as it comes in and actually plunges into the material. And that's only going to be a couple of seconds anyway, so there's no real need for it to be too quick. Ramp angle, spindle speed, those are also going to be if you're working with a mill, so we don't need to worry about those. Step over will cause things like this, where the current step over I have at 90, and we're not going to actually be able to cut everything because of the width of that bit and the path it's taking. But we can come down here, come back and change our step over, something like 55%. And then really that would probably not even stay at how small it is, but if you're worried about it, you can even come in and go to 50, and bam, it takes care of it. Pretty much the best way to look at that is kind of the same way that you probably mow your lawn, where you always come over and kind of overlap that last cut so you don't end up with little strips down the center. And this can, using a very low step over, even going below 50% will help you with, say if you're working on, maybe your bit is dull, or you're working with some wood that isn't really cooperating very well. I used some pretty much like, I ripped out a piece of plywood, or like pretty much it was, I want to say it was a piece of 2x6 out of our back scrap, and started cutting this exact shape into it. And I think I still have it downstairs. You'll see, even with the kind of wood it is, it's very soft. It kind of likes to fall apart. Because I did such a low step over, it still has where I cut is just as smooth as where it was cut to begin with. And then we can go and we can set up the next one. This one's also going to be a pocket, but we're going to go 0.5 on this pocket. Everything else, though, we're going to leave exactly the same. But a lot of you will want to change your layer. We're going to go for the middle, and then we've got the middle taken care of at a slightly different depth. Then we're going to go do the contour operation for the outer edge. In this case, we're going to do 3/4 of an inch, but you'll notice with the contour, it'll also ask you for your offset. You want to do an outside, inside, no offset. In this case, we want to do an outside offset, so it cuts on the outside. Everything else, I like how it works. Now, you can't just go hit the big green P this time. You got to go to Options, Machine, Post Processor, and simply change this to the router post processor. Do not ignore all of these options I have. You will have 4 options. You will have plasma engraver with THC, plasma engraver without THC, flame, which is for your oxyacetylene, and then you'll have one that says router, and you'll use that router one for your router. But and it'll explain that to you in the manual, but you'll simply switch over to the router. Now we can run that post processor. Really the difference is it writes the code now to kick that router on instead of trying to fire the plasma. Save it. Close that. Go to G-code. And you'll see all of that. You'll leave your torch height control off with the router. You'll never turn that on. Cycle start, and you will have zeroed your router just like you did your plasma. Bring it down to the material, rest it right there, tell it this is 0, and then it's going to go ahead and cut from there.
Going back up to the plasma. Would do like corrugated
So
stuff?
the biggest thing with corrugated is the normal corrugated you're going to find is so thin that the plasma more or less just melts so much material away, there's nothing for it to read. So if you want to do corrugated, you would have to do it no torch height, and you would have to do it at the peak and hope that you had enough power to make it through on the troughs. So normally we don't recommend corrugated. If you found some thick stuff with not very big peaks,
I see. So it won't follow good.
Exactly. The path itself isn't necessarily the problem. It's the thinness of the material mixed with the path. Normally, we've definitely done some high angles, and if it has material to understand where it's going, then it'll follow it. But with corrugated, it's normally like 20 gauge and below. Because it's so thin, you end up with this wide curve, and there's nothing for the torch to really read and understand.
But otherwise, it would.
Yeah, it will absolutely go up those paths. I think
Otherwise, they couldn't do expanded metal.
you can do expanded metal by turning your torch height control off, and that way you can tell it the exact height you want to cut at, the exact height you want to pierce at, and it's just gonna.
So it won't
just
be trying to read.
Exactly.
The topographic or whatever.
Exactly. Yeah. Yeah, you'd be able to, if you ever need to cut anything like that, just let us know. I'll walk you through how to change those settings, and we can change it over to no torch height control and tell it exactly where and how to cut, and then it's just going to come down and just ride across that expanded. You just got to make sure that it's nothing too big as far as the gaps. The plasma has a timer on it in the expanded metal mode of 5 seconds. So as long as at the speed you're traveling, you can get from one piece of metal to the next within 5 seconds, no problem at all. And then you'll see it's now stepped down into its second path and is now doing getting that full depth out of that one.
Did it start in the middle?
start at the deepest point and then.
So it'll actually start, in this case, it started here on the side, and then started to go back and forth, goes all the way across, and then it does one outside pass, and then it goes back to the first starting point and drops down again.
Oh, right, because you don't put a paper there.
Exactly. And you'll see right here, is our start point.
I guess it shows what it won't cut.
Exactly. Based on the width of our bit and how round it is, it knows it can't make it into that corner. If you had a smaller bit, it'll always change based on the width of your actual bit. So if I came in here and I adjusted our actual tooling, and say we had something like 0.4 or something, you'll see it get way further in there. But yeah, it's very good about with the router and the plasma showing you based on the width of what you're going to be cutting with, exactly what it can and can't do for you.
Can you change the different operations, like where it starts and stops?
Yeah, so if you wanted to change where it actually starts and stops at, the easiest way is if you click on this check mark, it'll get away the green stuff and allow us just to see our lines. Say on these guys we wanted to change where the start location is. Right here, edit start points. Anywhere on the line you click.
And like I say, I want to change that to S4.
So you can do that. Be careful when you're doing that though. Changing the location doesn't pull it out of the automatic optimization. If you change a number though, it'll stop correcting everything, and you'll have to go through and make sure every other pierce point is still where you want it. Where if you do it this way, it's always going to make sure, say with your plasma, that your insides cut before your outsides. But if you change the number of one, it may change the order, and you may have an issue where now it's trying to cut an outside before it finishes those insides. But just moving the location will not interrupt that. But if you did want to change the number, right click, properties, order, and you can literally change this number to whatever you want. But when you hit OK, this operation is set to automatically optimize. Changing the order will disable optimization. You want to continue. So I normally don't do that because then you have to manage all the other ones yourself. But if you do end up in a situation where you need to, absolutely a possibility. And then the tube notcher is really kind of simple. There's not a lot that goes into it. It's really just a final scaling at the end. Give me just 1 minute, gentlemen. I'm going to run to the restroom, get myself a glass of water, and I'll be right back, and we'll finish the tube notcher, and then I'll show you a little bit, a couple extra things with HiCAD. Like we've got a feature called vectorizing, which will allow you to take a JPEG internet photo, preferably silhouettes are normally the best to work with, and actually turn it into a CAD drawing for you. Kind of make an artwork a lot easier in long situations.
Yeah, I'm interested in that. Do a lot of stuff on it.
This will cut those two too.
I've seen one on American Choppers, they do a water jet on there. Is this plasma or?
That was
water jet?
done with our water jet.
It's a-
Yeah, same thing with the carbon fiber as well.
Pretty cool.
Yeah, I've definitely seen people do gears and cogs and stuff with plasma. You just have to do them, they have to be way bigger. Where with the teeth like that, at that fine, the plasma would just start melting them. But with the water jet, we've done those. We've done the carbon fiber wrenches. We've done some HD plastics, some real thick plastics. We've even done some wood with the water jet in the past. All kinds of different stuff with the water jet. Go ahead and stop that. Come in and that's not what I want to click in my iCAD. So, if you wanted to, let's do tube notcher first. So when you're working with your tube notcher, you want to do a reference box, but instead of your table, you normally want to do it the size of the pipe you're working with. So X is going to be your length of the pipe, Y will be your circumference of the pipe. So the way I like to do it, you can of course do it the mathematical way, get your diameter, do all the different formulas and stuff. Easiest way in my opinion, get a string or a piece of paper, wrap your pipe, mark it, and measure it. Simplest way to get your circumference. But if you're working with, say your pipe is 12 inches long, we're going to start with 0, 0, and then say the second point we're going to work with is 12 inches on the X by, say we're working with 8 inches on our circumference. So now you've got your reference box to show you where your pipe is and how much space you have to work with. You can do everything from notches to artwork to words. You can see our BurnTables one over there in the corner.
You said the circumference?
Yeah.
So it's like we just open that, like
and just flatten it out. Yeah, flatten it out. And what you'll want to do is draw whatever it is that you want in this space. Say you need some bolt holes in here. You can put your holes wherever you want. Or you can always as well, if you need them to line up, split it in two. And then you have one side and then the other. So let's say we want a couple of bolt holes. And go ahead and turn the quarters on. Go from here to here. Here to here. I'm just using these for a reference. Use that nice little P trick here. Go here, and then let's say we want a 1-inch circle. 1-inch circle. Get rid of the lines. So then you would have 4 holes, and these two would line up, and these two would line up. But say if that's all we need on this pipe for whatever we're doing. The biggest thing you have to worry about, it'll remind you this on one of the last pages in the manual, under the tube notcher section, but there's a simple change that we need to do. Grab the entire thing, including your outer box, and you want to, modify and we want to transform. We want to leave the width exactly the same, 12 inches, but no matter what, the height always becomes 6. What this does is, I know it sounds kind of silly, but it kind of converts it back into a curve. So that way when the machine cuts it, instead of trying to cut it on flat material, it understands it's cutting it on a radius, and it actually comes out correct. If you were to leave it how we drew it, you'd actually see on your pipe, your holes are going to be oblong, nothing's going to be exactly the way you drew it. But when you do this little bit, you change this to 6, it's going to kind of change how it looks, but when it cuts out, it's actually going to be correct on the pipe.
So no matter what.
Yeah, no matter what your Y was, you'll always change it to 6 when you're done. And then you'll delete that outer box, because we don't want to actually cut the pipe up, we just wanted to put the holes in it. File, export, DXF vector image file. The only difference though is when you come to the sheet cam, drawing origin. You want to leave it where you drew it because we drew it in a specific place on the pipe. If you do bottom left hand corner, instead of starting our holes 2 inches down the pipe or wherever we wanted them, it's going to try and start them right at the end. So we'll be drawing origin, and then it's going to leave them where we want them. But it's going to give you a little better idea of some of the stuff you can do with it. I've done some artwork on pipe in the past.
Oh, yeah. Oh, wow.
The only thing about artwork in the pipes, you'll notice, especially when you cut it up quite as much as I did all the way around the radius like that, the very back of the pipe is going to pick up a lot of slag from that. So what I normally do is I'll just, before I do any other painting, I will just douse the whole inside with black paint to the point where it's pretty much just dripping out. And that way, by the time you paint the rest of it, you don't even notice anything on the inside. It's just blacked out. Or you can do things like I've seen, like my coworker, our shop foreman, did one where he put 512 in a pipe, or area code, and lined it with vinyl on the inside. So it gives it this really kind of crazy teal color from the inside, and then the outside's all painted. But that kind of opens it up. I know a lot of people get the tube notcher, and a lot of your ideas are, notching pipe. But there's a lot more you can, of course, do with it since you do have that CNC component. I've been really thinking about lately kind of some of the stuff you could do in fences, in mailbox posts, stuff like that with the tube notcher.
Yeah, what I had in mind was a similar thing. It's like, hey, maybe I could even do when I'm done. I don't know how well I just play with it. But just split the whole thing in half so I can wrap it around an existing post.
Absolutely, yeah. And they also, I've seen with the tube notcher, one of the coolest things I've seen is a gentleman who made some really big chess pieces. And he only left the front where he just chopped the whole back out of it. So there's definitely probably things that I can't even come up with that you can do with that thing.
Could you do that? I wonder with the wood router. Would put a 4x4 on there. Of course, actually, that'd be quite a operation. So yeah, I'll dream about that one for a bit.
I've had some questions, but we've never tried. And one of the biggest things I'd be worried about with the router is, of course you want to chuck your pipe in there as straight as possible, but you're going to have your torque height control. So if you have a little variance, the plasma is going to be able to kind of raise with it. Where the router, you're going to end up with maybe deep spots and shallow spots, things like that. So we've never tried, so I don't really know it all. But with the plasma, you can definitely do any pipe up to 4 inches, you can get it that shallow.
I guess it's
Yeah, the tube notcher, it's simple. All your drawing up to this point will be the same. Then you'll do that kind of silly sounding 6 inches, but it'll make it so it actually comes out of your pipe correctly. So we're going to go to File and Vectorize. This is where you can actually go get a photo off the internet, preferably a JPEG, and cut this silhouette and turn it into a CAD drawing. So it'll always tell you the width and the height. I do recommend staying above 400 by 400 and below 1500 by 1500. Anything below 400 seems to come out not really arcs. It's a kind of very angular and choppy. Anything too big and you can actually upset the program and they never finish it.
Over 400.
Yes. And then you'll just want to, this box is always a little bit too big. Just drag it over and you'll have everything you need. First thing you want to do is restrict your color count to number 2. I'm going to go ahead and leave it at 0 and hit vectorize just so you can see some of the crazy stuff it'll do if you accidentally leave it there. And we're approaching that 1500 range, and that's kind of why it's sitting here taking a minute, but it's going to be kind of ensure that it's some of the best picture you can have. The bigger resolution, the better it's going to come out. But so with our color count at 0, it doesn't really know what it's looking at. It'll do some crazy stuff. You want to put this to the number 2. What you're going to notice though is it can be a challenge to get there. You can't just type it. So press and hold with your mouse, hit your right arrow key twice, like a mouse. Perfectly number 2 every time. And then now that it's at 2, we can go ahead and vectorize again. And once it finishes, you're going to see it look a whole lot different.
So you say you always want the color down too?
Mm-hmm. So I recommend silhouettes. They're going to be the easiest. I have seen by changing the color count, you can play with colored pictures, but it can be a very, very large hassle. You'll start to get a lot more details that come in, a lot more random different lines, where white and black is going to help maintain the simplest path and the easiest for the computer to figure out. Then, if you have a small drawing, you can use the sparkle and the speckle to kind of play with how it picks up the lines. When we're working with these big drawings, you can see that it picked up pretty much every line that was in there. So with these kind of things, I normally don't mess with any settings. I just change the color count and vectorize. When you're working with smaller stuff though, you'll start to see that it may not come in perfectly. Then you'll notice we got a couple of different colors here. And it's because it came in on multiple layers. So highlight everything, right click, change layer, and we're going to put it all in one. Simply get rid of anything you know you don't want. Now I'm saying in this case where you can see, oh crap, that's definitely going to cut that out, and you can't even cut these. So you may want to get rid of something like that. Same thing with this. But then you'll start to find out, well, I kind of wanted some of that detail. So sometimes you'll have to break it up and leave certain lines.
Yeah, I guess you could oil grade.
Yeah, absolutely. Where a lot of mine, so like import, and I've done a couple different versions of this.
Yeah, it's going to keep that too. Somebody had a white Dodge Charger or Challenger, and they had some sticker pattern they had but the whole thing kinda had that cool looking.
That's awesome.
Going feature. But, yeah, black stickers.
So this is the first one I cut. You can see I simply removed the line from up top so I can still cut this, but not cut everything out. Same thing with these.
I got you.
This sucker sits directly inside my house at a solid 2 feet tall. But this is my final edit. I actually like this one a lot better, where I changed what it cuts and what it doesn't, and this ends up turning out a lot more like an actual stormtrooper, like the way you think of it. Where because of some of the extra lines, this one comes out kind of an artsy version. But you have complete control over what you keep and what you don't. One thing you want to watch out for, though, the one issue with vectorizing, it uses polylines. And you have some of the worst select collections of straight lines making up your arcs. So you can see in this case, I simply redrew his head with a couple of lines. But one thing you may find out, say with Boba Fett here, terrible, just the worst line here.
You know, I had run into a problem like that, and it was an older AutoCAD, and you could select all your polylines and change it to I don't remember, it was options, just like you can, and it gets rid of all that, makes one clean arc. I didn't know if that was an option.
I don't think it is, not one that I found. But one thing that's really cool, Sheet Cam, those white dots are the same thing as those blue squares. So Sheet Cam sometimes can figure that out and smooth out that arc for you. So what I'll do is I'll kind of come in and I'll vectorize something and I'll delete those things I know I don't want anymore. And then before I start cleaning up everything else, I'll take it over to Sheet Cam and see what Sheet Cam can do for me. But let's see real quick. The only option you really have here in HiCAD is what they call a So I think the only thing in HiCAD you have the option of is if I wanted to if we wanted to join them, so that way it's one object, then you can spline fit, and a lot of times it can help with that, but then you can see it does silly things like this.
Maybe it was something like that.
Well, and it may even be just an evolution beyond where this is, maybe. I want to say that's about the only option you have. Oh, good Lord, I don't even want to know what I was doing. You can, and what I've noticed in HiCAD, the problem is they do have a feature that you think sounds cool, but if I click directly on the node, erase node. But eventually, it'll start becoming just one straight line instead of maintaining an arc with less nodes. And so, you can only do it one by one. There's no way I've found to be able to do multiples. So really the easiest and the fastest way is to just delete that line, draw an arc there instead, or see if Sheet Cam's going to do something for us about it. But HiCAD will help you with a lot of artwork and getting started where you don't have to draw the whole thing yourself. And then you can email us. My email's on that business card. And you're more than welcome to email me and remind me to email you guys these. And I have like 3,000 almost different files. That's exactly that. Just random DXF files. I'll open up a couple random quick. But so,
Do I need to, I didn't even ask about the, air supply. So I've got a compressor, or just hook into that, or?
so it will, the plasma just has a normal air line on the back of it that you hook into.
I have a power or hypertherm, small one.
Okay,
I don't
yeah,
remember what it
same
was,
thing.
But, okay.
And then the only thing that'll be special is you want to make sure you're maintaining at least 10 SCFM at 90 psi. As long as your compressor does that or more, then you can hook into the plasma, and the plasma has its own automatic air mode that will regulate itself from your air supply. Then you will have to add, and I'll show you exactly where, for the engraver, there's one airline we don't include just because we don't know how long we're going to need it to hook up to your system. I recommend getting yourself a little 1/4 inch airline. They refer to it at Home Depot or Lowe's as refrigerator tubing, the same line they use for the water for your refrigerator. 1/4 inch line goes from a quick connect on the engraver solenoid. I recommend tapping it right into your plasma airline. That's how we have ours.
Okay.
Right before it comes into our plasma,
Instead
it
of
tees
flipping
off.
that.
Yeah. And it just goes right to that. And then that way you can just make sure that it always has air, and your plasma and your engraver are never going to be working in the exact same moment, so they're never going to fight each other for air. But I've got some random stuff like this, file wise, but I've got like 2,500, 3,000 files.
Yeah, okay.
So just email me and remind me, and I'll email you guys over the files I have. Some of them, if you're going to switch over to something in HiCAD, you probably won't deal with this. So some of these are made with AutoCAD, but they were made with, like, say, AutoCAD 2010, and they were saved as a DXF 2010. And AutoCAD, for some reason, has decided since 2000 to randomly start changing different things about their files. So a lot of your new softwares, SheetCam, which is licensed, has no problem opening those new ones, but HiCAD does not understand it. Some of these files I have are absolutely fantastic and ready to cut.
Cool.
Some of them will need a little bit of work to deal with. This one you probably want to do a fair amount of engraving. Watch out sometimes for this. Some systems, they don't have softwares like SheetCam, and they actually have to draw their own lead ins. So if you see that kind of stuff, you'll just want to get rid of them and then make sure that you close that path off. But there's all kinds of farm stuff, military, motorcycles, a couple different AR silhouettes.
Yeah, stuff like hot rods, like 31s and stuff like that.
Actually, I do. Actually, there's a. So, where is it? The biggest folder that I'll send over, it's poorly named new folder. It's got about 2,000 files in it. If you start in the numbers, so the first few aren't, but once you hit about 20s, I think, 30s.
There you go.
And then they just keep going.
So, on that table, how big of a, say using that chalkboard there for an example, can you make a pretty sizable?
Absolutely. So he has a full 5x10 cutting space. So you can literally.
Like say if I wanted to just use that chalkboard right there as an example, that isn't a problem.
No, I think that's probably about the exact same size as the cutting surface of the table probably. You'll see our table downstairs is a 5x10, the one that we're going to go play with here in a few minutes.
So we can't go too much bigger than that.
Yeah, not too much bigger, but probably about the exact same size.
Okay, I was going to say even if it was a foot down,
You could probably split that up so you could put more.
Oh yeah, I've seen some guys do some really, really good work at taking a drawing, cutting it up into several pieces, and then putting it back together.
Yeah.
Go ahead.
That's cool.
And we'll head downstairs. I guess it's just sitting here recording itself.